In this example, Unit 1, Lesson 3 on proportions, we are going to apply what we learned about proportions to triangles. So with triangles, we say two triangles are similar triangles if the ratios of the pairs of corresponding sides are equal. And that sides is a typo, so you might want to cross that out. Consider the two triangles below. We see that side AB, which is here with a measurement of 3, is corresponds to side DE in the bigger triangle with a measurement of 9. Also, side BC in the small triangle corresponds to side EF in the larger triangle. And finally, side AC, the bottom side in the smaller triangle, corresponds to side DF in the larger one. So these triangles are similar, and I'll show you why. If we look at the ratio of side to corresponding side for all of these sides in both of the triangles, we'll see that that ratio is the same. So 3, well, let's do this. AB is to DE as BC is to EF. And finally, AC is to DF. So if we plug in the numbers, we have AB, which is 3, DE, which is 9, and we want to see if they're similar. That should be equal to BC, which is 4, and EF, which is 12. And then finally, AC, which is 6, to DF, which is 18. And if we reduce each one of these, 3/9 will reduce to 1/3 if we divide the top and bottom by 3. 4/12 will reduce to 1/3 as well if we divide 4 and 12 by 3. And finally, 6/18 reduces to 1/3 by dividing the top and bottom by 6. So since the ratio of the corresponding sides are equal, we say this triangle is similar. And this will allow us to find a missing side by setting up a proportion with just 2 of the corresponding sides. Also, triangles are similar if they have the same angles. So if these angles are congruent, then we know the sides have this relationship as well. So let's look at an application of this. So in this example, we have the shadow formed from the sun shining over a tree. So when the sun is at a certain angle in the sky, a 6-foot tree will cast a 4-foot shadow. So if we draw this tree and we say it is 6 feet, and then it's casting this shadow, and so the length of this shadow is 4 foot. And you can see that this forms a triangle. We look at the height of the tree, the length of the shadow, and this line here, which is the hypotenuse for this one, because this is a right angle. So what we're asked to find is the height of a tree that cast and in this example, it would be a 10-foot shadow. So if we draw another tree, of course not to scale, and it's casting this shadow, but this time we don't know how tall the tree is, but we do know that the shadow it's casting is 10 feet. And here's our triangle with the hypotenuse here. So these triangles are similar. They're both right triangles. And so the sides are proportional is what we're assuming. So if we set up a proportion with this triangle, we can also find the missing side. So we would say x is to 6 as 10 is to 4. So I'm using this side corresponding to this side and the shadow corresponding to this side. So now we have a proportion. If we cross multiply, we have x times 4, or 4x, is equal to 6 times 10. So 4x is equal to 60. And if I divide both sides by 4, I'm going to get x is equal to 60 over 4, which reduces to 15. So a tree that casts a 10-foot shadow is going to be 15 feet tall.